Let's begin. Okay, thank you everyone for joining us today in this webinar. On the call within the panelists, we have 5 of us here today. Those include myself, Michael Logos, the VP of Product and Strategy of the company. We have Patrick Gołąbek here, who's the CTO, and then Robert Gołąbek as well, who's our CEO. We also have Erwin and Stacy. They're part of our executive team as well. They're standing by in case there are any questions that might be specific to them. This presentation is all about reducing the complexity of working with Kubernetes, with Kubernetes and DevSpace. We have Patrick on the call here. He had curated a video that we're going to be going over, which will jump into a specific use case around how you can leverage Kubernetes for an application development. And we'll also go over some additional points about who we are as a company, some challenges that you might face with Kubernetes and why you might want to get some assistance in that regard. And we'll also talk a bit about our newest product offering, Kuber, which is a comprehensive toolkit to evolve your Kubernetes journey. We'll also give a couple minutes at the end of the presentation to facilitate any Q&A if there are questions. So Translucent has been around for 13 years. We've been established since 2010, and we are a cloud-native software development company, specialization in Kubernetes modernization, machine learning, and other types of innovative technologies. Our mission is really centered around what we can do, and that is namely to leverage state-of-the-art machine learning and cloud technology for our clients in this effort to build business value through software innovation. So the challenge with Kubernetes is that Kubernetes is a really powerful orchestration platform for containers, and it allows you to scale your software development capabilities in your development environment by this concept of containerizing your microservices or whatnot. It, however, produces a number of complexities and considerations that you must have in your software development environment. So it's really important to weigh out the pros and cons of Kubernetes before you jumpstart into the Kubernetes journey. One, while it's flexible and sophisticated as a container orchestration platform, it really does increase complexity in a multifaceted way. So your software development environment might become really complicated if you decide to go with Kubernetes. However, Kubernetes is part of the open source community. So this allows you to get access to all of the benefits that an open source community has on offer with respect to the number of different tools that come out every year and the number of companies that participate in this environment. However, when you jump into Kubernetes, you have to utilize the tooling that's associated within this community, and it can be overwhelming, particularly for IT teams that are focused perhaps on developing the core technology in their business. Now you have to think about Kubernetes and how to deploy and manage that effectively. It might kind of distribute the thought process that your IT team has with respect to their technological environment. Managed Kubernetes vendors exist to kind of make this complicated scenario a little bit easier for companies looking to jumpstart into Kubernetes. However, they do come with rather significant costs, and the potential for vendor lock-in exists. So this may not suit every organization because it's important to consider that you might get that help, let's say, early on in your software development maturation process. But however, once you develop a team that is really capable of running Kubernetes on their own, you might be stuck with that vendor and the costs associated with it. So this is where Kuber comes in. Kuber is your essential toolkit to accelerate your Kubernetes journey. It is a set of key Kubernetes toolkits in essence, and these are comprehensive toolkits for organizations looking to accelerate their Kubernetes potential. It's developed with infrastructure as code principles at its core, so this allows for increased automation of your deployments, and it is a unified toolkit as well, providing an integrated set of tools that allow you to accommodate all the Kubernetes needs you might have, from development to management, in a production-ready package. So in other words, these are pre-configured packages that allow you to really jumpstart in your Kubernetes journey. And we have 3 packages that are designed for specific stages in that journey. So the first one is Jumpstart. It is your ability to have a stable and smart and observable Kubernetes environment. This is for organizations that might have a Kubernetes environment already, but they need to have it in a production-ready manner. The other 2 packages are for organizations that are a little bit further down the Kubernetes journey. So Essentials is related to incorporating intelligent application observability. And then we have our third package, which is our growth package, which is all around continuous DevOps innovation And then we also have additional features that really allow you to play with the differentiation in the Kubernetes space. Just quickly, I'm going to touch on 5 elements that encompass this advantage of Kubernetes. One, like I mentioned, Kubernetes is a very complicated beast that can be overwhelming for many people just starting off with the technology. So with Kubernetes, pre-configured toolkits allow you to minimize that integration burden, preserving that depth of control that you might desire. And with that, you receive simplified management as well, because those tools are pre-configured. You do have this hassle-free setup and management that occurs. We also, being Kubernetes specialists, shepherd that journey so that you do end up having a Kubernetes environment that indeed is simplified compared to if you were to go about it alone. And it is a little bit less complex compared to building your pre-configured solution that might be missing tools, might be requiring a little bit more complicated coding. Also, automation is something that is across all of our platform toolkits here. We have Terraform scripting that allows for repeatable version controlled infrastructure. And then, like I mentioned before, because you're part of Kubernetes, you now have access to the cloud native community, and you really do get access to the best that community has to offer. This allows you to stay ahead of the curve when new tooling comes out that really incorporates those innovative features. Being part of that community really allows you to take advantage of those tools sooner than if you were to go with, let's say, a managed service provider. Finally, we have Nexakube. This is one of the features that are within the community that we are rolling out. It's an intelligent AI assistant, and this allows you to streamline and automate a wide range of tasks of interactions within Kubernetes. And this leverages generative AI, it leverages LLMs, and it's something that we're really proud of what we built. And if you want to take a look at more about what Kubernetes might mean to you, by all means, contact me, Patrick, Robert, or the team after the call. We'll also provide our contact information at the end of the call. So with that, we're going to go into the meat of the webinar. We're going to be talking about a Kubernetes application journey from development to deployment. Patrick Gołąbek had created a video that is going to take a use case here, talking about how you can create a Slack bot within Kubernetes using FastAPI and DevSpace, also leveraging our Kubernetes architecture. So with that, we can start the video.
Welcome, everyone. Today, we're diving into the exciting world of Kubernetes, which is a powerful platform for orchestrating containerized applications. To illustrate this, we will develop a containerized application. We're going to create a Slack bot. Before diving into the code, let's examine the Kubernetes application development and how to build the Slack bot application. Starting with developing applications for Kubernetes. Kubernetes provides a system for automating application deployment, scaling, and operations, or simply, it's a container orchestration platform. In developing for Kubernetes, there are several key aspects we need to consider. Application architecture design is one of those aspects, which really means crafting an architecture that leverages Kubernetes strengths. An example of such architecture is the microservice application architecture. Containerization involves packaging the application with all its dependencies into a container. Writing Kubernetes manifests, these are YAMLs and JSON files that describe application desired state within Kubernetes. Local development and testing, that refers to ensuring our application runs smoothly in local development environment. Monitoring and logging, well, they're essential for maintaining the health and performance of applications within Kubernetes. And the last aspect there is deployment strategies. Understanding different strategies for deploying application in Kubernetes is essential. Let's talk about the strategies to make Kubernetes development smoother. We can use local Kubernetes clusters like Minikube for a simplified setup. We can leverage development tools such as DevSpace or Scaffold and others, which streamline the development process. We can take advantage of the cloud-based development to shift the development resources to the cloud. And finally, we do have to think about the sustainable growth of the system. As the project evolves and the system grows, it is essential to plan for long-term scalability and efficiency. Here's a diagram of different Kubernetes clusters you can deploy or install on developer's machine. This simplifies the Kubernetes management and also increases the resources on the developer's machine. Here we have a chart comparing different dev tools that enhance the Kubernetes development experience. We can maybe linger on some of these for a second here. For example, DevSpace, scaffolding, and Tilt. They provide end-to-end development experience. We also have their test containers there at the end. It's a really good tool for integration testing. For today's session, we have chosen DevSpace. It is a Kubernetes development tool that simplifies the development process. It comes with really attractive features like hot reloading, declarative workflows, and it really kind of optimizes the development process. We can also use DevSpaces with a local cluster, deploy locally on a dev machine, or with a cloud cluster, which allows us to shift again the computational resources to the cloud from local machine. Choosing the right development environment is crucial. It depends on factors like team size, project complexity, available resources, budget constraints, frequency of development and deployment is also a big one. So here's another chart here. We can probably linger on this one for a bit. So whether you opt in for local cluster development or for small teams, or cloud-based solutions with DevSpace for mid-sized teams or large enterprises, the key is to balance cost effectiveness, resource usage, scalability, and operation simplicity. When it comes to DevSpace and cloud clusters, you can also use them with small teams as well. I find it very useful to offload any kind of workloads from my local environment. Now, in conclusion, the right tool or the right tools and strategies can make your Kubernetes journey not just successful, but also enjoyable. Let's now explore how to build a Slack bot application for Kubernetes. The Slack bot application comes with several key features, such as responding to Slack channel events. It actively listens and responds to activities within the Slack channel. The bot can access and manage Kubernetes resources. The bot also provides interactive two-way communication. Users can engage with the bot using mentions and commands, and the bot responds with interactive elements like buttons. Here's a screenshot of one such interaction. Let's go through this one here. So the user uses bot mention to send a message to the bot. Now the bot responds with a message that they're sleeping, at which point the user sends a trigger phrase to wake up the bot. The bot responds with interactive elements, buttons in this case, asking the user to make a choice. Based on that choice, the bot provides additional feedback. Now, the technology stack behind the Slack bot application is both powerful and intuitive. We're using a FastAPI, which is a modern web framework for building high-performance APIs in Python. We're also using the Slack Bolt framework, which simplifies handling Slack events, actions, and commands. We also deployed Redis database, which is there to support any data needs the bot might have. The database and the web application are containerized, and the containers are stored in a container registry. Let's dive into the bot Kubernetes deployment architecture. We deploy the bot in its own namespace, which ensures logical separation within the cluster. We'll deploy it with ingress, which manages the entry point for the bot service, routing traffic to the bot service. We deploy the bot service and deployment. These are the core components that run the Slack bot application. And then we deploy the Redis. And we also deploy additional tools to support secure communication and the DNS configuration as well. So here's the diagram of the Kubernetes architecture. We can see that the user interacts with the Slack channels there at the top, and the Slack servers send information back to the cluster, through the load balancer, through the ingress, into the bot service, into the bot deployment. And this is where the FastAPI web application is running, which processes the interactions, the events. It can also access Redis and sends them back to the Slack servers, to the Slack channel. Now we can see at the bottom there, we have those additional tools we mentioned, things like the external DNS for managing the DNS, the cloud DNS, to automatically create domains for us, certificate manager, the cert manager there, which provisions Let's Encrypt certificates for the TLS. And there's additional tools that are not part of this picture. So these additional tools are tools that we always deploy within the cluster. They're part of the KubeRT observability package. And they're there to cover all the observability needs, which are tracing, metrics, logs, and exceptions. And under these categories, we deploy different tools. Here's a picture of all of them kind of combined. This is how we wire those tools behind the scenes as well, conceptually speaking. So in conclusion, the Slack bot is a testament to the power and flexibility of modern technology stack. By combining FastAPI and the Slack Bolt framework within Kubernetes environment, we created a scalable, robust, interactive application. Let's jump to the code now. Let's dive into the code. The code has been already pushed to GitHub. We also provided GitHub pages with additional documentation. Once you clone the projects, there's a few things that we have to do to customize the project for your own development. So let's start with customizing the Kubernetes manifest, the different YAMLs that describe the deployment into Kubernetes. So the first thing you should do is to update the ingress YAML. This is where you have to define your domain that's going to be used with your Slack bot. And there's several places when you have to add this domain. One is here for the external DNS, so it will automatically create the DNS entry for you, a new cloud DNS. Additionally here, you provide the domain here, and here this is just for the rules and also for the TLS as well. The other thing you have to kind of configure is this cluster issuer here from our certificate manager. Again, we have documentation in the GitHub pages to show you how to find the correct cluster issuer for you. Now this is going to automatically provision the TLS from Let's Encrypt for you, so you can have TLS secure communication, HTTPS communication. The other thing you want to update is the service monitor, which depends on the Prometheus deployment. So we also have the notes in GitHub pages to show you how to get the how to find the label here. This label comes from the Prometheus deployment. This allows you to wire their service monitor, which collects metrics to the Prometheus deployment they have within your cluster. Okay. The other thing you have to configure is the Slack application and get some credentials from it. So let's just have a look at that first. So when you log into Slack and you create your application, this is what you will see. So this is our webinar application here that we created. Once you create the application, it will provide you with this app credentials here. We need the signing secret. The next thing we need to configure is the permissions. So we only give specific permissions to the bot, and in this case, we're adding the app mentions and chat write permissions. Once you add these permissions under the bot token scopes, it will create this token for you, and this is also what we need for the communication with the bot. Okay, so once you have both of these things, then you can create this env file. We do have a template of it here, a backup. You can use this to create your own env file. In this case, we have the bot token and the signing secret. These are the only two things you need. So once you have all this, you're ready to start developing. Now, actually, before you start developing, one more thing that you need to kind of configure is the images that will be building part of DevSpaces. So we have another file here, configuration file called env DevSpaces. There's also a backup, a template file here. Now, in this case, we need to define the image names for these two different images that I'll be using during the development. And you want to provide a full repository name, and in this case, we're using Google Container Registry, the GCR. So this is the format of GCR with our cloud project. Also, we're kind of combining them under one folder in our registry, so they're all under webinar, so it's easy to find them after. So once you have those images, once you configure Slack and you update your devs deployment YAMLs there, Kubernetes YAMLs, you're ready to start developing. Okay. So let's go through DevSpaces first before we jump into the code. So DevSpace YAML is where we configure DevSpaces. Now, while we talk about DevSpace, I'll just kick it off. Let's just start it off. So here I'm going to run a command to actually kick off my DevSpace dev environment here. And in this case, I'm providing the Kubernetes context and the namespace. Again, we have information in the GitHub pages how to configure your Kubernetes context, create a namespace, so you're ready to go. So in this case, I'm going to kick off my DevSpace dev environment, and it's running now. It's deploying the systems. Let's talk while it's doing this. Let's talk about the configuration itself. So the env DevSpace file we use to actually create these variables here. So then you don't have to kind of hard code them. We can just provide them with your own env file. At the same time, we did customize on pipelines here for dev and deployment. And we'll go into it while we customize them in a second. We also have here a section on building images. So this is where we define how we build those two different images. And we have some arguments that we pass during the build time just to make them those images more versatile. We also kind of define this strategy to ignore context changes. So this means that we want to basically build the images when we call a dev build explicitly. So we don't want to build them all the time, just to kind of improve the efficiency of development. We don't want to build images every time we run DevSpaces, only when we need to. At the same time, we're using a build kit here as a container engine here. DevSpaces supports just regular Docker engine and Canonical and your own customized engine as well. We're using build kit in this specific case because it provides it's very efficient in building multiple images in parallel in your local environment. Also, we do define the platform. A lot of guys have, for example, Macs, which are ARM, and we need to be able to define the CPU platform, the architecture as well. So in this case, we're building the main server image here. We're building a dev optimized image just for development. And we also have a Redis database image here that we build as well. Okay? And they're built and pushed to the registry in the cloud. We're not using local registry in this specific case. So here's how the deployment looks. Now the deployment can use Helm chart, customize. In this case, we chose to go, which is vanilla Kubernetes manifest YAMLs. It's just easier to show how things work. So we're deploying all the YAMLs from this DevSpace deployment folder here. We're deploying the Kubernetes proxy, just the application itself, and then the Redis application here, or the Redis database deployment here. Yeah. Now, to make it more customizable, we also patch some of these YAMLs during deployment. So this gives us kind of ability to inject images, and we don't have to hard code these images. So if I go into my deployment here and I look at the deployment and look at the image itself, it says replace me. Okay, this means that I need to provide a correct image there before it's put to Kubernetes, and this is what happens in our DevSpace YAML. In this case, we're patching that container image here, you can see here, and the value that is provided here comes from our customized pipeline. So we inject it here. So we grab those images here. Okay. So that kind of gives us a way to externalize the configuration all the way from the Kubernetes YAML to our configuration to this env dev spaces, and you can provide your own images here, and doesn't impact the rest of the manifest and the pipeline. Now, if you go a little bit further down, now we have the definition for the dev pipeline, the development process here. So what happens here is we use the deployment both for this manifest here, deployment here, both for deploying the actual application, also for developing application. Now, during development, what happens is we look for that pod that's deployed and we replace the image there with the dev image. Okay, so we do have two different images, and we have two different Docker files for each one. We'll go through in a second. So it gives us now ability to replace the it could be the production image or your deployment image with your dev specific image, and customize the tools within the container, and at runtime replace that. We're also kind of specifying how we're going to sync the environments. In this case, I'm syncing my local directory here with the container within the Kubernetes cluster. And when the container starts, it executes this start bash script here. As you can see below here, it says translucent here. This is straight from the script. And at the same time, we're also proxying a couple commands here with the SSH. So this allows us to use these commands from our local machine, not in the cluster, and we don't have to package them in a Docker file. So it makes a lighter Docker file as well, or the image as well. And here we're specifying the port that we can access the container from. So if you look at the script that we deploy here, so in the script, what happens here is we kind of bootstrap the container with the libraries and all the things we need for development here. So in this case, we're installing Poetry, and we are configuring and installing those libraries from Poetry. And Poetry is our package manager. Manage the libraries, the Python libraries. And it starts off a bash shell. So once we have this, we can kick off the application. In this case, we created a special run Python file here, which just runs the FastAPI application in development mode. Okay, so let me just kick that off. There you go. It starts our application. Now, application is available on port 3000. So let's just have a look there. So there we go. It says, welcome to the webinar. Now, at the same time, it's also available this public domain. So Slackbot text apps. So this is when the request goes to the Kubernetes ingress. So if I show you an image here quickly. So when we go through the domain, we go through the load balancer, the ingress, and then we get forwarded back to our pod, and the pod then is forwarded to our local machine, right? So that's why we can access from 2 points. You can access it locally, and you can access it from your domain as well, your public domain. Okay. So that gives us 2 entry points to the application, one local and one from the public domain. Now the public domain is needed now for further Slack application configuration. So once your server is running, this is where you can actually configure additional features within the Slack application. So in this case, we're going to configure the event subscription. So this allows us to send messages in the Slack channel with the bot. So see, in this case, we provided our public domain in here that was provisioned by the external DNS, and the HTTPS, which is from the certificate manager. Let's encrypt, and we're providing the Slack event here, which is the route in a FastAPI application. We'll go through in a second, and also we allow the bot to subscribe to this app mention. So every time we have an app mention, the bot is going to be listening to that and responding to its events. So this is how you configure events. So now the events will be coming in on this RESTful endpoint, and we can code against that RESTful endpoint. Now the verification happens only when you have the application running. That's why it's essential to get the application running first with basic credentials, then come back to Slack application and then enable these events. We also enable the interactivity as well. So this is where you also have to provide request URL within your application as well. So this is why you also need the public domain in here. Okay, this is why we need the ingress configuration. Okay, so that's all that we have to do for the Slack app application configuration here. Okay. All right, so before we have a look at the code, let's have a look actually how it works. So let me break up the Slack channel. So in this case, we invited the bot into this channel. So if you look at your integrations in here, you'll see that here's my webinar Slack bot. We added to this specific channel. And now we can use app mentions. So this is an app mention, I can talk to it. So I can say, hello. And you can see at the bottom there, it's executing. So the request is going again through the public domain into the cluster and back into, we can see in a local environment, local development here. So it created a thread for me. It's saying it's sleeping. I'm gonna ask it to wake up. And it's asking me how am I feeling. I'm gonna say I'm feeling good. And then it responds with a quote. Okay, so this is the happy path interaction here with the bot. Now let's go through the code and see how it looks. All right, so let's go first through the ETL process. Okay, so the quote that we see here at the end from the bot that was displayed here, this is coming from our Redis database. So the bot has access to the Redis database. Now we have to populate the data. So we have to run an ETL pipeline, a very basic ETL pipeline, to be able to extract these quotes from a CSV file and import them into our Redis database. So here's the ETL process. I'm going to stop the server right now. And I'm still within the container. I don't leave the container here. I'm just going to go to the ETL folder, run a make file here. We can see we have one make target. Let me just execute it. Now this is running within the cluster again. So if I show you the configuration file here, this is a Kubernetes Redis service here that we're talking to. So we're directly within the container, and we can access all the other resources within the cluster. So we're actually accessing the Redis deploy within the cluster directly. And we extracting data from these files here. We got from HubSpot. These are just quotes. It gives you a quote and a person. And we're running, using a script here to just kick off a Python job here that does the work for us. So if you scroll down to the source, on the jobs, we have here Redis job in here. This is where we execute this ETL job here process to be able to extract. If I scroll a bit lower here, so there's a bit of configuration here where the files are. And here we have Redis DAO. And we create the index. So we're using the search module from Redis, and which allows us to create a search index similar to Elasticsearch on MongoDB. And once we have the index, we just run a pipeline where we read the files and then we push the entries from the files into Redis database. And if you look at the output log from what we just ran on the logs in here, you can see that, if I scroll a bit lower here, you can see that index was created and was deleted, and then we created a new index and we imported all these different documents. Okay? And now we can do searches. Okay? So that's for the ETL process here. So I'm just going to hide some of these things just to make it easier to see. So now, let's open up the tests and let's open up the code. So this is what a Slack bot is, the FastAPI application. Okay, so we're using here, if I scroll a bit lower here at the bottom to make it, I don't want to make you sick here, but we're using this factory pattern here with this create app method here, where we actually create the FastAPI object and we configure it and we run it from here. So a few things to kind of point out here. So when we kick off a new development, we want to cover some of the basic things, these kind of non-functional requirements, and functional both when you're creating the project. In this specific case, we're talking about kind of observability things, right? You want to get them out of the way, you want to configure them before you start diving into your business logic. Okay? So in this case, we're trying to configure all these things within our FastAPI here, create method here. We're defining the metrics, the logs, and they're all customized specifically for Kubernetes. So for example, let's just go into the logs quickly here. So in this case, we're configuring the loggers, being mindful that this is running in a Docker container and we're going to be scraping the Docker logs, and we want to format the logs in a very specific way so it makes it easy for us to scrape these logs. So in this specific case, we chose to go with JSON format. So we have a JSON formatter here that we also customize here as well. You can probably review it later. It's under here, JSON logger. So in this specific case, we're customizing the logs into converting them to a JSON format, and we sending them to standard output. It's out. So then we can see them in Docker logs, and then the Docker logs can be scraped by observability stack. In this case, we're using Promtail and Loki. So Promtail is scraping those logs and putting them into Loki database, and then we can use Grafana to query for these logs. Okay. We also, if I go back to our application, create FastAPI application here. The other thing we customize here is metrics. So in this case, We are using Prometheus middleware here to configure metrics. And we also defined a RESTful endpoint for metrics here. So these will be standard metrics that we're collecting from the web server. Now this endpoint here, this metrics endpoint, is what we have defined on our service monitor here. So in this case, this is what the path is. So we're telling the metric scrapers from Prometheus to scrape this specific endpoint that we configure within the application. Every 30 seconds, it will scrape that specific endpoint. Okay. And we do customize it a bit. We want to skip the health checks here. So we also define health checks. Now, health checks are required for Kubernetes probes, liveness and readiness probes. In this case, we have very kind of basic health checks. You can see all it does is just returns just 200 saying healthy. Now, this is used by the deployment YAML here. It's used by the probes. You can see there's liveness probes here. Hits that endpoint and checks it every few seconds to see if the container is alive. Same thing for readiness probes. Ideally, you want to have two separate endpoints, one for the health check, one for the readiness probe. They just have different business meanings. So you want to customize that. It really depends on the application as well. When the application is ready, it could depend on databases, it could depend on the messaging bus. You just have to define those business rules for your specific use case. The liveness probe is more straightforward. If you can't access the container, it will just die, and Kubernetes self-healing will kick in and refresh the container. So it's very simple. The readiness probe is a little bit more complicated. You want to make sure the system is ready to accept your traffic, your requests. It's good to go. Getting back to our FastAPI configuration. So it's a basic health check here. Scrolling below here. So after that, we just define the error handlers. So we can have consistent error handling. And then we define the different routes. So the basic routes are the health check and just the root one. Now when it comes to the Slack, we define, where's my Slack routes here? So below right here. Here you go. Here's where we define the Slack configuration here. So we define the Slack routes, and then we define the middleware, which are the business logic that gets executed once you get into any of these routes. So just have a look at the routes first. So we configure the application, and the Slack application here, you can see that it requires the token and the signing secret. These are the two credentials it needs from the configuration. Okay. Here's the Slack event endpoint that is required to enable, when you enable events. This is the request URL I need to provide, and this is the interaction one. Okay, so that's all within. We just have two endpoints: events and interactions. Okay. Now, most of the logic happens here in the service or the business layer here for the FastAPI application. So we have a middleware here. So this is a concept that comes from the Slack Bolt framework. To use the concept of a middleware. So we configure the middleware here. This is where we define different kind of integration with the Bolt framework. In this case, we're defining a simple middleware for log, just to spit out logs, just to show you what's happening. We have another one to handle errors that happen within the, communicating with Slack in the channels. And we have one here for app mention, so when you actually mention the bot. And then we have interactions here, one for the good and one for the bad button. So there's two buttons here that we respond to. Okay, so this is how we wire the middleware and the events and the interactions for the Slack Bolt framework. Now, all these different functions are defined in different service methods or modules here. For example, if you have a look at the event handler here, so here, this is where the app mention happens. So we, in this specific case, we get the event, the payload from that we get from Slack, and then we pass that on into our Slack service. So we just grab the body, the payload that we get from Slack, and then we forward it up to our event handler here in the Slack service. So the Slack service here is where the business logic is. So this is where we handle the events. In this specific case, we look at the payload coming back from Slack, and we check if it has text. And if the text has the word "wake up," which is a trigger phrase, we process the command. So if the wake up trigger phrase is given, we ask the question, "How are you feeling?" and we send that message. At the same time, we also add action buttons to the message to be able to ask for feedback from the response. So in this case, we're sending 2 buttons, good and bad, and these buttons, when you click on them, there's another event handler that happens behind the scenes to that you can wire your business logic to as well. So in this case, once you have the trigger word and you get the response with the buttons and you click on them, this is where the interaction service takes over and does the work. So in this case, you have an example where we click on the good button. So in this case, we return feedback immediately to Slack. That's just a requirement. And then once the feedback to Slack is returned immediately, then we can process the response. In this specific case, we get the settings which are required for our database. So let's go back and discuss these settings for a second here. So settings is where we define so here are the settings for the database in this specific case. So we have our database configuration here. Now this is basically read by our configuration class and creates our settings object. Now this settings object is then injected into our routes and into the middleware. So if we scroll a bit lower here, let's start with going through the routes specifically here. So so here we go. So here's the event. Now this event here, so let's go through the interaction more precisely. So then we can, so this is the interaction here. This is where we pass in the settings here. So this is the settings configuration we got from our environments variable here. So this is the database credentials. We just inject them into our handler. Okay. Now if you go into our function here, let's look at the interactions here service. So here we pull those settings out of the context, and then we just pass them on to our Slack service here. So in our Slack service, in this case, we use the settings to get the search index where the codes are. Okay. And then we just grab the codes. So this is we grab the codes. So we just basically search the index. We get just a count of them, and then randomly just pick one. And if one exists, well, if anything exists in the database, we just randomly grab one here, and we just return it. And once we do the database query, that search, going back here, once we have that quote, we just return it to the user. Okay, so that kind of gives us a two-way communication. The Slack bot asks you for feedback with the buttons. You click on a button and you get feedback. So it shows you kind of two-way communication. Okay. So now let's just have a look at testing, because it's a big part of obviously development. In this specific case, we have both unit and integration test. We can just execute all the tests in here. Let's just run all the tests here quickly. So you can see you can just run them from your IDE. You can also execute them directly from your your console as well from your terminal within the container, if you choose to. Let's just have a look at one of the tests here. So let's just have a look at, for example, Slack routes test here, just to give you a sample of how the test looks. So in this specific case, we're using the PyTest framework. We're using PyTest mock as well to mock our, well, anything that needs to be mocked within specific test, things that's not under test. So the system under test is not mocked, but everything around that would be mocked. So I'll just give you one example here. So in this specific case, let's just, here's a bit of a better example. So we're testing if we don't have the setting within the route, so it should throw an exception here. Okay, so yeah, we check it, we run it, and then it should throw an exception, and if it does, we check what the message and exception is, and we know that it's working here, okay? So another interesting thing to point out is the integration test. For the integration test, in this integration test is testing the Redis DAOs that we created. Now, we don't have to use DevSpaces for everything. There's test containers is just another tool that we mentioned before that is very valuable when it comes to integration testing. So in this specific case, we configured the test containers here, the Redis test container. Okay, so if I scroll a bit lower here, you can see there's my my Redis container configuration, and it grabs the latest image. Okay, and if I go back to the test, we're actually using that specific Redis container here. So it starts it up for us automatically, and then we just configure the credentials for our DAO, and then we use our DAO to test in different methods within the DAO. Like for example here, if I scroll a bit lower here, in this case we're testing if we can add an index with the DAO. Now these tests, when they're done, the container is cleaned up for us. So let's just have a look at it, an example. So if I open up my Docker desktop here, so if let me just run the test here quickly, all the tests, and then let's see what happens. If I execute this, go back to my Docker, you can see that we're going to see a couple containers show up in here, test containers. Once they get started, there you go. There's the test containers, the tests execute, and then get it cleaned up. They're done. Okay. So that kind of gives you an ability to do almost real life, real world testing with actual container, and fully automate the creation and destruction of these containers as well. Okay. Let's have a look at the containers now. So we do have two different containers. So going back to DevSpaces and the container that we're within right now. So that container we are in with right now is a very simple container here. So this is our dev container. So this is it extends just a Python parent container here with specific version that we need, and installs the tools that we need. In this case, we're giving a little bit more developer tools here, things like DNS utilities and curl and get, which we'll never install in a production container. So this is just it's good for debugging any networking issues. And as you can see, that's all it has. It just has basically tools. Yeah, it's just a Python base container with just a Python version installed, and then just these Linux tools here to help with development. Okay. Now, if you look at the production container here, it's a bit more complicated. So this is multi-stage build in here. In this case, we're building using multi-stage build to have a very small final container. So in the first stage, we do all the heavy work, heavy lifting. When we install the tools, we install the libraries, and then that's all it's used for. And then the next stage is where we actually use the stuff that we built in the first stage. And this is the final container that you will see or deploy to production. Okay. So let's also have a look at some of the different commands we have in DevSpaces. So one of the commands, so let me open up a new terminal here. So if I click a plus sign here, I can open up new terminal. I'm still have access to my container, so I'm still can go back to my Kubernetes container, do work within Kubernetes, and I can do things outside of Kubernetes here. So DevSpace UI, let's just kick this off, and it's gives me this URL here. I just go back to our so if I make this a bit bigger. So this is a tool that comes with DevSpaces that kind of gives you a little bit more feedback about what's happening. So in this case, I can see the different deployments. So I can have a look at my Slack deployment here and have a look at the logs as well. Same as the Redis, I can inspect the Redis here and open up terminal into the container and do some more work here. Additionally, when I look at the stack in here, that kind of gives you the information about your DevSpace deployment YAML here. So you can have a look at it here. Additionally, one more feature here is commands. So these are very useful for repetitive commands for developers have to do. You can wire these commands and execute and just automate your work. Any way to reduce the toil, you can just use your DevSpace commands to do that work. Okay, let's close this up. So let's end it here then. We'll provide you with a link to GitHub, and we'll obviously send you the slides. And if you have any questions, just reach out, review the code, have a look at the way we wrote this application and how we put the whole thing together for you guys, and just give us feedback. Thank you.
Okay, so that was a video from Patrick. Let me just switch the screens here. Robert, if you want to turn off the video, then I'll just put my screen up. Awesome. Okay, so that was the video. I hope that it was informational in the sense that Patrick had gone over how to build a Slack bot leveraging DevSpace and other tools. You can really see from the demo here that there's a lot to consider when you think about Kubernetes. It's not just Kubernetes itself, but it's everything that comes with it. So relating this back to Kubert, it's really important to have something that simplifies this process and also have something that allows you to understand how you can get to the point in your journey where you really go from development to deployment. So thank you for participating with us here today. We do have a few minutes that we can spend on questions if there are any. I have our contact information up on the screen as well, in case anyone wants to reach out to the team here after the call. So yeah, if there's any questions, please throw them into the Q&A. I'll open this up as well just to see if we have something. Okay, I see a question from Brad. You talked a lot about observability, and there is indeed a lot of conversation in the community about observability. Why is this so important? What problems does it solve from both a technical and business operations ROI? So I think that question might be most applicable to Patrick. Do you want to take a stab at this? Maybe Rob, if you want to kind of interject there with respect to your perspectives on observability.
Sorry, guys, I was just muted here. Yeah, so I did provide the answer there to Brad's question. Observability is crucial, right? You have to know what's happening in your system, and this is kind of well, From a business standpoint of view, it just leads to, to understanding your customers, any issues they might have, any potential issues they might have, and dealing with those issues. And sometimes you know the issues before they happen as well, before the user actually experiences those issues, right? So observability in general, it's essential for understanding your health and performance of your application.
Great. Thank you, Patrick. Are there any other questions? In the Q&A, I see, oh, there's another one here. How does Translucent and the solutions that Translucent have, how does it simplify the process for developers and overall managing Kubernetes?
Sure. So we just went over DevSpaces. So DevSpaces is a tool that simplifies the development process just in general. It kind of provides you with a way to deal with kind of common things you have to do during a Kubernetes development, and you can automate these things. And also not only that, you can, as a company, provide consistent development environments all across your company as well. So you can actually manage that from a company point of view as well. So it just leads to better outcomes if everybody is using the same kind of stack, the same tools. And if you leverage DevSpaces and the automation of it, it also allows you to build an application faster, reduces the operational cost.
Great. Okay, thank you. So there are a couple more questions that have come my way. I think they're both addressed to you, Patrick. So here's the first one. There were a lot of tools shown in the demonstration. How did Kubernetes fit into it? And how did it specifically show how we can leverage Kubernetes to build that Slack bot that you had shown with DevSpace?
All right. So you can think of Kubernetes as the underlying infrastructure that hosts the Slack bot. And the reason it's attractive to use Kubernetes is because it has lots of kind of good features to manage the application. Things, things like, when it comes to scalability, things like self-healing. So when your application goes down, it restarts. So using Kubernetes as your underlying infrastructure with all these benefits, it really helps you to get, first of all, time to market is much faster, but also you can have a better experience for your users, and also your operations, again, operation efficiency goes up as well. And the DevSpace is just a tool that kind of streamlines the Kubernetes workflows for you.
Okay, awesome. Thank you. There's one question left, also to you, Patrick. Why do you use Kubernetes for a Slack bot? Compared to other ways of creating a Slack bot, what benefits does it offer to leverage Kubernetes specifically here?
Right. So, well, going back to what you said to the last question, when you use Kubernetes, it offers kind of significant kind of features like scalability, reliability, management, efficiency, all these different kind of things, because it is a full orchestration platform, right? So it gives you, and when we say orchestration, it's about managing your application. So you get all these orchestration features out of the box of Kubernetes. And anytime you build an application and you start focusing on the business logic, it's nice to have a platform that it can handle all the kind of non-businessy, all the technical, the system stuff for you, and that's what Kubernetes gives you. So it allows you to kind of focus on your business application, not necessarily on the infrastructure, and it just makes you, it reduces time to market for you to build an application, deploy it to your clients and customers.
Okay, awesome. All right, thank you, Patrick, for those. I don't think there are any other questions. So I think we can end the webinar here. Again, really, I'd like to thank everyone for spending the time here. It's been over an hour where we really talked about what we can do here in the space with respect to Kubernetes and Kubert specifically, and then also going into that example with DevSpace and some of the elements that encompass Kubert as well. With that, like I said, is our contact information on the screen. You can email us directly, or you can contact us through our website at translucentcomputing.com. If you're interested in learning more about Kubert, any of the 3 packages that we talked about today, or if you're interested in booking a demo, please feel free to just reach out to us through the website. Okay, thank you so much. Have a great day.